Good afternoon, everybody, and welcome to this presentation on what we've learned about Delta Live tables. So myself, Chris Inkpen, and my friend and colleague here, Paul Mracek.
Nailed it.
Yeah, I'll get there one day. So we have been working together for the last year and a bit on building up a occupancy modeling predictor using as many different data sources as possible. And today we're going to talk about how we've used Delta Live tables to provide this service. So let's start off with an introduction to Honeywell. Honeywell is a gigantic company. It has well over 13,000 employees, and it occupies most of the globe. There are several divisions: aerospace, building technologies, performance materials technologies, and safety and product solutions. So aerospace is basically anything to do with flight. We tend to get involved there from the aerospace. Performance materials and technologies, everything to do with process control. Safety and productivity solutions is keeping the workforce safer. And building technologies is all about keeping our buildings safe, secure, comfortable, and sustainable. So we manage, Honeywell have over 10 million buildings have our technology in them. So we have a large tap of data to play with here. And we really, really do focus on IoT solutions. We have focuses on delivering cloud solutions, plus delivering edge solutions. But today's focus is more on what we're doing in the cloud. So about the end of last year, the Databricks guys actually contacted me and asked if they wanted to do a write-up on how we're using Delta Live tables. So if you do a Google search for Honeywell Databricks, you'll find this report. And in this report, there will be a lot more detail about how we've utilized DLT and some of the pitfalls and some of the workarounds that we've used. So at peaks, we will consume between 200 to 1,000 events coming from all the different sensors in the building. So each building is giving us maybe up to 1,000 events per second. So we have a large collection of IoT data to deal with. And that corresponds to billions of data points per day. So ingesting billions of these rows of sensor data into Delta Lake is how we've utilized Delta Live tables. We wanted something that really could cope with the sheer scale that Honeywell Buildings has to offer. And out of the box, pretty much DLT, Delta Live tables, has given us something we don't have to worry about. It will handle the scale of whatever we throw at it. And mostly that's thanks to the Microsoft Azure platform, the IoT event hubs, and the Databricks and DLT. So that's kind of our technology stack that we've pulled together. So if you can put yourself back to March 16th, 2020, basically that's when COVID hit our town and we were told to leave the premises. So back in March of 2020 is when we basically went into a lockdown. And one of the hackathons we did at the time was, global hackathon we did, was to look at all the data that can help us to identify where people are in the building, because now it's changed the rules of how buildings are managed. So our goal is to make the building sustainable, healthy, and comfortable, and we wanted to use a hackathon to assess where the different sensors we could use. And you can see here we have this is a PIR sensor representing a state change every about 40 times a second, so it's got quite a fast refresh rate. And as people move in front of it, you can actually see movement. And if you were to actually throw a cup of tea at it, it will give you a significant movement. Not something that you should do, but I obviously did try it for purposes of analysis. Yeah, and there's the tea being thrown all over it. So you can actually infer an awful lot of information from this signal. but really, it's an awful lot of number crunching to do that. And so we tend to use PIR sensors really to indicate there is at least one person in this building. We don't know how many, but we know there's at least one. If you look at all the other different technologies available to measure people and measure where people are, you've got cameras, you've got the thermal images there. They are probably the best way of identifying where people are, but it's also the most intrusive. People don't tend to like themselves being videoed, cameraed, and it's a lot of privacy concerns, but it is by far the best accurate way of measuring occupancy. PIR sensors up in the top left, but a whole host of different technologies you can see on the list. The ones that are particularly interesting are CO2. CO2 is a very interesting sensor. In a space, people generally breathe out 0.05 meters cubed of carbon dioxide an hour. And we can use this over time to indicate how many people have been in a building or how many people are currently in a building. It's a very, very slow lag, but it is an indicator of occupancy. So if we can work out where people are, we can make our buildings safer. So whatever the customer has, we want to be able to integrate their sensor data. The other interesting one is connected power. Connected power is another one of our industries in Honeywell, and they offer a connected socket that can actually determine what the load profile associated with it is. So if somebody's got a mobile phone or someone's got a laptop connected, it's another indication that there's probably people in there. So lots and lots of different technologies, including audio, ultrasound. There's lots. And the challenge is really to use whatever the customer has in their building. We don't want to force them to have a whole host of other sensors, but we do want to be able to use whatever they do have. So on the left-hand side here, you can see all of the different types of telemetry data. Even parking. Parking gives you an indication that people are in the building. Not a definite, but it is an indicator, and that's what we're looking at here. You've got HVAC, heating, ventilation, and air conditioning for those who aren't into the BMS, building management systems world. And that is generally a building, when it's commissioned, is set up at a schedule of, say, 9 to 5, Monday to Friday. That's generally set up when the building's commissioned and then forgotten about. So regardless if people decide to not work Wednesdays and Thursdays, you're wasting a ton of energy here, heating and cooling a space where people there are no longer there. So the outcomes we're looking for here, much better facility management to only target heating and cooling spaces when we really need to. Notification evacuation, of course, because we're dealing with fire and security. We want to be able to help identify where people are in the building to assist in any evacuation if required. Improved indoor air quality. CO2 is quite a heavy set of molecules, and it's actually a nice carrier of pathogens. So the more CO2 you have in a space, the actual greater chance of carrying pathogens around the building are as well. So there's another reason to monitor CO2. It's a very cheap way of identifying the likelihood of pathogen spread. But indoor air quality, we want to make sure that where people are, their space is nice and breathable without risk to their health. So one of the main sources of occupancy is Cisco Spaces. I don't know how many of you have heard of Cisco Space. Does anyone know what it is? We have 2 people, great. So to the rest of you, you can now know what it is. So Cisco Spaces is a cloud data service that runs on top of the Cisco infrastructure. So you can imagine pretty much in every building, I'm just looking up if there are any here, but you will generally see your Cisco access points up in the roof space, in the ceiling. And what they do is they can actually listen to the pings from your mobile phone as your mobile phone is trying to connect to Wi-Fi. It can also with your laptop, as your laptop tries to connect to Wi-Fi. it's continuously letting out a ping, and the access points can pick up those pings. And we can, by a process called trilateration, which is if you know where the access points are in space, and you have something moving through space, like this red circle, then you can get a noise between the device and the access points, and there's a direct relationship between noise and distance. If you know the distance of these devices from the fixed access points, you can actually calculate its XY coordinate. And so we can use this to determine where something is in space. You'll see on the animation that when you have two access points, you've actually got two different locations because you've got two circles interlapping in two locations. So it doesn't help having two access points, but by adding the third access point, it's able to identify the position far more accurately. As you can see here, you've got two different positions where that can be. So that's the process of trilateration, not to be confused with triangulation, which is what everyone thinks that is. It's that triangulation works with angles, trilateration works with distances. Just thought I'd educate you on some maths there and physics. So the next thing we wanted to look at is the Cisco Meta Streaming API, and this is what it looks like from Cisco. So this is Cisco Spaces, their own dashboards. And the bottom, we have a floor plan from our headquarters in North Carolina. The green dots, let me just see if there's a green dot, a red dot on a green dot, for those who are colorblind. The green dots are authenticated clients. So these are people who have authenticated through the Cisco access point. The red dots, so I'm going to do a red dot on a red dot, which probably won't work very well there. That is a unauthenticated device, so that would be more likely a personal phone. We don't know who that phone belongs to, but we do know there is a phone there. And this data can be presented from Cisco to customers like us as a stream. It comes as through an event hub or an IoT hub, which we can read using Kafka. And at the top, you can just see the sheer scale of IoT data coming from Cisco. Honeywell has about 750 buildings. We have over 8,000 access points. So we are actually one of Cisco's highest customers. And so we're a great test bed to actually try out this Cisco Firehose API. So that's the challenge. I've kind of set the scene. We have all of this telemetry data, millions and millions of data points, and we want to try and combine it. So this was our design sketch to indicate how we were going to go from bronze to gold. The gold we've already talked about, which is optimizing the comfort, optimizing health, and energy prediction and energy reduction, and sustainability. Those are the outcomes we're aiming for. But in order to get from bronze to gold, we have to mix it with what we call our building metadata. And the metadata we have is represented by this diagram here. And the Honeywell are all about people, spaces, and sensors and equipment. And these are the relationships. So equipments consume energy. Energy is monitored by sensors. Sensors are monitored by Honeywell. And so you can see kind of the interrelationships here. And it's this metadata that we mix with our bronze data to start providing some of the outcomes. But without the metadata, we just have raw data. It means nothing. So at this point, I'm going to hand over to Paul to give you some foundations in our design and architecture.
Yeah, we were joking earlier that this is the podcast intermission ad read here. Unfortunately for you all, you can't fast forward 30 seconds at a time. But as I was working with Chris, starting 18 months ago, just listening to this, hey, we've got this torrent of data streaming in. We've got to mix it with this batch. Delta Live Tables was even a little newer than back then, but it was like, man, this thing seems like it's a really good fit for it. I'm not sure who, I would guess most folks have a little bit of familiarity with Delta Live tables here, but I will explain just a little bit about what it is and how it works. So Delta Live tables is the way that Databricks sees ETL in the best way to do ETL on the lakehouse. It really blurs the lines between batch and streaming. So being able to join these sensors that are coming in rapidly with that more static or slowly changing ontology data, you can do both of those inside of the same pipeline, and Delta Live tables will just handle that for you. The key word that people say is declarative. I don't really like that word because I feel like it's more just tech data engineering jargon. But the way I like to think about it is focus more on the transformations that you want to do with your data using SQL or Python. So if you can write a create table as statement in SQL, you can write this streaming pipeline, no problem. One of the great things with DLT is that then we are going to take over the operations and maintenance and management of that pipeline and the output data set. So a lot of data engineering in the past with Spark structured streaming, maintaining checkpoints and the actual file layouts and maintenance of that file or of those tables when you have lots of small files, that all goes away because we are managing and maintaining that for you. And of course, since we know all about the transformations and the different things you're trying to do with it, we actually provide you a way to add data quality expectations on top of your pipelines. And we will monitor your data quality for you as the data is flowing through. So what does that actually do for an organization? Well, Chris and I are living proof that this can accelerate the development and the innovation and delivery of new pipelines. We recently got together in Atlanta, and over the course of 2 days, we built a production-grade data engineering pipeline to score data sets with the machine learning model for a slightly different project. So anybody can get started really quickly with Delta Live tables because it meets the developers where they are. Using SQL, if you're a business analyst or a data scientist who maybe PySpark is a little scary, or if you're a data engineer, use that PySpark. It doesn't matter. They're both first-class citizens and will get you where you want to go. And then the last one, is maybe the biggest thing on organizations' minds is how do we limit cost? Well, yes, you're giving up some control when you use Delta Live tables because we're now managing the clusters, we're now managing the scalability of that. And so you might think, hey, I'm a little scared or worried that this is going to maybe Databricks doesn't have my best interest in mind. But in reality, the total cost between the pipelines, those generally go down because we get smarter about how the pipeline runs and we can scale up more effectively. And then also the cost of people, don't forget that. These pipelines are just so much easier to maintain and to use. So the ad read is done. Back to the star of the show here to take you through the rest of the way.
So what I wanted to do now is to show you the actual results of running DLT, Delta Live tables. So on the left-hand side, we have our data coming in through Kafka. Again, I've not had to worry about using Azure Event Hubs, Kafka, and Databricks. I can really deal with as much data as Cisco is willing to send to me. And it's called a Firehose API for a reason. It really does send you every telemetry data about a device moving through any of its locations and spaces is sent in real time. So it's important to be able to consume it, and it's also very important to be able to filter it and partition it into various different ways. So the types of partitions you can see on the right-hand side, we have events to show us when a device enters or exits. We have a regular event like every 15 minutes, it will always send a device count. So even if you're not interested in Honeywell, and Cisco Spaces is extremely useful for anyone who has a building. Anyone who has buildings and Cisco equipment in, you can take advantage of this stream of data, and maybe you can build it into your own pipelines. But it's extremely useful for us in Honeywell because it's by far the most non-intrusive way of estimating occupancy. And that's what we're all about, is making our buildings healthy. So we need to know where people are. So we got device location updates. That's physically like that red circle moving through space. Every significant movement, we would receive an event from that. And then this is one part. So what we're looking at here is really just the Cisco part of our big pipeline. So all those other technologies like CO2, PIR, they all have their own pipelines. And they all come together. Actually, at this point where Paul mentioned, we now combine all those sensors together in order to make an effective occupancy, like PIR, CO2, Cisco. But this is just showing you the main selling point from my perspective of DLT, which is the sheer scale that we can handle and visualize what's going on. So the first one I showed you was actually our production. This one is more of our R&D service. This is our playground. Right now we're looking at a technology called, we call them lick and stick. We haven't got our marketing department on it yet. It's a sensor that you can literally, probably don't have to lick it actually, but you stick them on the wall, and they are BLE beacons. They give you temperature, humidity, lighting levels, and they actually don't even need any batteries. They are harvesting the light and storing the light from the space. And those are outputting BLE beacons, adverts, which the Cisco Space infrastructure can pick up. So we can actually now use the Cisco infrastructure to pass our telemetry data, whereas before we would have had our own infrastructure, our own wiring in a building. Now we can actually take advantage of somebody else's infrastructure and get it securely delivered to our compute engines. So this one is basically at the bottom here, we have all the telemetry data coming in from these Bluetooth beacons, and that can feed us raw telemetry data from our buildings. The other types of things we can do is mixing streaming data with static data. One of our customers, internal customers this time, our global real estate, were really interested to know where all the Mac users were. Now, they wanted to know where they are because the way in which they were being monitored before was with a Windows service. A Windows service actually indicated when they logged in. And so they had a big blank of people, particularly in some of our design centers in China and Atlanta, where there didn't seem to be anybody. And then they realized it was because they had Macs, and the Apple didn't run a Windows service. So what we could do is we could actually mix the well-known MAC address manufacturing database with the device IDs coming in real time to tell them where the Mac users were. So very useful to them, but it really, to you, it illustrates mixing streaming data with static data. So what I wanted to kind of really now focus on was some of the design challenges. If you're interested in building your own DLT pipelines, we have so much experience of that, and I want to try and pass some of that design and frustration work that we had to you, so you can be more accelerated. So this was a live retrospective that we had after the end of our delivery, which is why it's Post-it notes on a Miro board. So this was, just wanted to keep it authentic and keep it real. So in order to show, visualize the pipelines, it helps to know that by having a visualization of a DLT pipeline, as you saw in the previous 3 diagrams, it gives you a feeling of what's going on from data ingestion to gold table delivery. I find it very hidden. If you just have a whole load of Spark notebooks, it's very hard to actually see what's going on. But visualizing the transformations through bronze, silver to gold is a real delight, particularly when you know you've got a good design. It kind of shows you that it makes sense. The other key factors, and there are lots, but some of the key factors I love about DLT is its automatic optimization and vacuuming. I know you can do that yourself, but generally I find our developers don't. So we end up with extremely inefficient Delta tables, and it's often a cause of extreme cost to us in Azure as well. If you don't optimize your Delta tables, then the storage API to the cloud layer is extremely chatty and extremely expensive. So do optimize your Delta tables, and you don't have to worry about it if you use DLT. It does it for you. So that's a great winner, and in fact we saved $100 a day just by identifying some Delta tables which were not optimized. Apply changes. The merge operation in Python I find is really confusing, but the apply changes operation in DLT is beautiful. The fact that you just specify the keys, you specify the sequence by, and it handles the merge operation for you. The other beautiful thing I love is the Z or Z ordering is extremely flexible in DLT. You can just customize it. If you don't actually know what the best way this data should be indexed, you can just change it later when you do actually start to know how this data is going to be consumed. And some of the other things are putting reset not allowed, some of the detailed DLT pipeline stuff you can put. So you can put do not reset this Delta table. For those who have used DLT, you can do a full refresh, and if you do that a few times, you suddenly realize, well, I can't actually get my original data back anymore because it's run out at the Kafka level. The Kafka has now auto-cleaned it up, so you've lost it. So the first thing I ever do is to stick a do not reset on any of my Kafka sources. Everything else can be recalculated, but not that. Mockable sources are absolutely fantastic. You can take one of your main sources as a notebook and replace it with a simulation, particularly if you use the rate stream to give you some streaming data. But that gives you the ability then to automate and the automate unit and integration tests on the whole pipelines. So there's loads. I really, really love it. Everything I do is in DLT now whenever I can. There are some circumstances where you can't. Right now, you can't write to an event hub from DLT. But speaking to Michael just a few minutes ago, he assures us that that's coming in minutes, in Databricks minutes. So I think we're kind of at the point now where we really do believe that DLT is actually sped up our development.